Hi guys, welcome back to another video. So we're still going through the Stroud Engineering Mathematics book, and we're on the trigonometry chapter. We're now on to half equilateral triangles. So an equilateral triangle is a triangle whose sides are all the same length and whose angles are all equal to 60 degrees, or in radians, pi over 3. So one thing I just want to mention here is, if you haven't come across the unit circle yet, take a look at it. You want to give this a Google and just get familiar with this. This is basically how we convert degrees to radians. So obviously we've done a bit of that in previous videos, but it'd be a good idea to just get used to it. So you can see 0 or 360 degrees is 2 pi, 60 degrees is pi over 3, 90 degrees is pi over 2. So you can see we just mentioned here that the equilateral triangle has 3 angles of 60 degrees, or pi over 3 radians, which is this one here. So just become familiar with that, okay? So the second right angle triangle of interest is the half equilateral triangle with side lengths, again by Pythagorean, in a ratio of 1, square root of 3 and 2. So basically just taking this equilateral triangle and cutting it in half. A very good straight line. That's what we're doing. So here you can see that the ratios here are 1. So the the hypotenuse is 2, right? Here. So you can see that this is half of that. You've cut it in half here. This is half, making 1. And the ratio of this line, this center one here, as it relates to this and this, is going to be the square root of 3. Cool. So the same as what we did in the last video. If you look at it in terms of x, we say that here is x. We say that here is 2x. And we say that here is x times the square root of 3. So whatever this value is here, if this is 7 centimeters, then this becomes 14 centimeters. And this becomes 7 centimeters times the square root of 13. Cool. Okay. So now he's going to make some relationships here we'll go through. So sine 30 degrees is equal to cos 60 degrees, which is equal to 1 over 2. Sine 60 degrees is equal to cos 30 degrees, which is equal to the square root of 3 over 2. And tan 60 degrees is equal to 1 over tan 30 degrees, equal to the square root of 3. So let's break this down, because that is one huge mouthful of stuff to consume. Cool. Okay. So let's start with sine. We'll do it over here. Let's start with sine 30. Right, sine is the opposite over the hypotenuse, right? And so in this instance, when we're talking about in terms of ratios, 1, 2, 30 degrees, square root of 3, 60 degrees. So sine 30 is the opposite. The opposite is obviously 1, and the hypotenuse is obviously 2. That's the opposite of 30 degrees, and this is the hypotenuse, right? The adjacent would be square root of 3. Okay, so now what we've said here is that sine 30 is equal to cos 60. Well, let's do cos 60. Cos of 60 is equal to obviously the adjacent over hypotenuse, right? So this angle here, what's its adjacent, right? You should know, 1. And what's its hypotenuse? Same as sine, 2. So are these two the same? Yes, they are. They're both 1 over 2. So therefore, we say that sine 30 is equal to cos 60. Pretty cool, right? Okay. Now let's take a look at the next one. The next one that they covered is sine 60 is equal to cos 30. So basically just the inverse of these two. Sine 60, which again, as we've said, is opposite over hypotenuse. So we're just talking about this angle here now. So what's its opposite? Its opposite is square root of 3, right? Square root of 3 over 2, right? Because the hypotenuse is still the same, 2. And then if we do cos 30, then what do we have? We have the adjacent over hypotenuse, which is equal to the square root of 3 over 2. So think about it, right? Cos of 30, so katoa, adjacent over hypotenuse. The adjacent of the angle 30 is what? Square root of 3 divided by 2. So we can say that sine 60 is equal to cos 30. And this is where you really want to be comfortable with your SOHCAHTOA. Just a quick reminder. Okay, so the last part of this bit is the tan 60, which is equal to 1 over tan 30, which is equal to the square root of 3. Okay, so tan 60 is equal to the opposite over the adjacent, right? TOA, which is equal to the square root of 3 over 1, right? So we've got, go for that again, in a different color. So the angle is 60 degrees, right? The opposite of it is what? The square root of 3. The adjacent of it is 1. Square root of 3 over 1 equals what? Square root of 3. Cool. Okay. So now here's the $1 million question. He wrote that tan 60 is equal to 1 over tan 30. Right? Keep in mind TOA. Right? Opposite over adjacent. So this is what he wrote. Tan 60 is equal to 1 over tan 30. How does that work? So I'm going to draw another triangle. Trying to illustrate it because I've drawn all over that one. So if we have a triangle, we've got A, B, and C, right? Let's say we've got the angle 60, and obviously this angle is 30. This angle here is always going to be 60. Why? Because remember we're talking about the half equilateral, right? So this angle up here is 30 as well, total into 60, right? So you just have to keep that in mind. This angle is always going to be 60. This one here is going to be 30, always, right? So we can say that tan 60 is, remember, SOHCAHTOA, opposite over adjacent. So the opposite of the angle 60 is B, right? And the adjacent is A. So tan 60 is the same as saying B over A, right? And then we're saying, or the author's saying here, that this is equal to 1 over tan 30. So how does that work? Well, let's work out tan 30. Remember, tan 30, we're talking about this angle now, right? So what's the opposite of that angle? And what's the adjacent of that angle? The opposite of that angle is A, and the adjacent of that angle is B. So tan 30 is equal to B. We're saying that tan 60 is equal to 1 over tan 30. What's 1 over something? 1 over x, right? It's the inverse of x. So, or I'll explain it a bit more in case you didn't get that. Okay. So 1, we're saying 1 divided by tan 30, right? We're saying that that is equal to tan 60. Okay. So let's go through 1 over tan 30, and we've said here that tan 30 is A over B. Right? So we're saying 1 over A over B, which is another way of basically saying B over A. Again, if you're not comfortable with that, Khan Academy is your best friend. You just want to go through those lessons, and you'll get used to it. The algebra ones, I think they covered it. That's what I did before my first year in electrical engineering. So what we're saying here is that 1 over tan 30 is equal to B over A. Now, where have we seen that before? B over A, right? We're saying that 1 over tan 30 is equal to B over A. Well, we've said here tan 60 is equal to B over A. So what does that mean? They're both equal to B over A. Therefore, they are both equal. Meaning, sorry, tan 60 is equal to 1 over tan 30. Why? Because tan 30 is A over B. Here. Tan 30 is A over B. But 1 over tan 30 is flipping them, making it B over A. And these two are both B over A. Cool. That was quite a long-winded explanation. So for this next part, this bit here, I'm not going to do the same explanation. But just one thing you just need to just know. Remember this unit circle that I mentioned over here? We're just literally converting degrees to radians, right? So here you've got sine 30. This is the same. Sine 30 and pi over 6 are the same. Why are they the same? Because the angle 30 degrees is equal to what? Pi over 6, right? Likewise, cos 60 the same. You know, obviously 1 over 2 is equal to 1 over 2. That's fine. Sine 60 is equal to pi over 3. Sine 30 is equal to pi over 6. Since these are all equal, they all just have the exact same relationships. these two are basically just the exact same statement. One's written in degrees, the other one's written in radians. It would be a bit like if you wrote this part up here in English and you wrote this part in French. Just because they're in different languages, they're still going to be exactly the same. Cool. Okay, so let's just go. So now we've got x here, right? We've got 2x here, just remind us, and then we've got the square root of 3 here. So let's carry on with the question. So here's an example using these new ratios. A tree casts a horizontal shadow 8 times the square root of 3 meters long. So that's our x. If a line were to be drawn from the end of the shadow to the top of the tree, which is this hypotenuse right up here, it would be inclined to the horizontal at 60 degrees. That's fine. So the height of the tree is obtained as follows. Height of the tree divided by length of the shadow equals tan 60 equals square root of 3. Okay. Alright, so let me so I could just read this. If you got that, then if you understand this, then this is the end of this, pretty much the end of the video. But let me go through it anyways, because I know the first time I read this, I didn't get it. Okay, so what they're asking us to do is they're asking us to find the height of the tree, basically. What they're telling us, the height of the tree is obtained as follows. Okay, so let's obtain the height of the tree. All right, so what do we have? We have, right, the angle, which is 60, and we have the adjacent, right? You see that? The adjacent of the angle, 8 times the square root of 3. What do we want as it relates to the angle 60 degrees? What do we want? Do we want the hypotenuse? Do we want the adjacent? Or do we want the opposite? So obviously, we don't want the hypotenuse. They're not asking us to work it out, although we could work it out. The hypotenuse would just be 2 times this. So we want the opposite. So this should jump at you now. We have the angle and the adjacent, and we want the opposite. What does that sound like to you? I'll write it again to remind us. So, So we have the angle and the adjacent, and we want the opposite. So we've got the adjacent, so it could be cosine, could be tan, and we want the opposite. So it's not going to be cosine, it's going to be tan. So what do we write? We write tan 60, right, which is equal to the opposite over the adjacent. Okay, so we say tan 60. What's the opposite in this situation? It's the height, right? Height divided by, what's the adjacent? 8 times the square root of 3. Okay, so here's pretty much where the magic happens now. So tan 60, what we could do, and this, if you did this, you'd be right to do this, but you'd miss the point of the way that the author's trying to teach it here, which is we could just translate this tan 60, use a calculator, work out tan 60, and then times that tan 60, whatever it is, by 8 times the square root of 3, and then that would give us the height. But we've already worked out up here, no need to do that. We don't even need to use a calculator actually. We've worked out all the way up here that tan 60 equals what? The square root of 3, right? Tan 60 equals the square root of 3. Remember, we worked out here. So then we know then that height divided by 8 times the square root of 3 is equal to the square root of 3. So what do? We times both sides by 8 times the square root of 3. That gives us height is equal to the square root of 3 times 8 times the square root of 3. So what do we do here? We just multiply these two together. That gives us 3. And then we're left with our 8 still. And then 3 times 8 is obviously 24. And we're dealing in meters, since we're talking about trees, and trees aren't centimeters. And that's it. We've got the height. So we could have done it from here and worked out tan 60. But you can see if you know and get used to x, 2x, and x times the square root of 3, just get used to knowing that tan 60 is equal to square root of 3. And then we can work it out simply. Cool. And just to check our answer, this is what the author did as well. Height of the tree is equal to the square root of 3 times the length of the shadow, which is this bit here. So okay, so yeah, he's worked out here that tan 60 is equal to the square root of 3. And then his height of the tree is equal to the square root of 3, which is this tan 60. And then he's times it by the length of the shadow, which is what we did here. So he's got square root of 3 times 8 times square root of 3, which is what we did. Times these two together to get 3. Then he's got 8 times 3, which is 24, which is exactly what we did as well. Cool. And that's that. We did it, guys. So I shall see you in the next one. If you found that a bit shaky, watch the video again. No harm. Leave a comment down below if you have any questions. And just go through this unit circle. I'd say once you get used to this unit circle, things get a lot easier for you. Cool. Alright, guys. I'll see you in the next one. Peace.